So, title of the talk, Jigsaw and OSGi, what the heck happens now? I should actually say the original title I submitted was, what the hell happens now? Apparently hell was too offensive for the program committee, so I had to kind of Ned Flandersify my title here. But I think a better title is to allow you, with your dirty minds, to fill in the blanks in this alternative. So, WTF happens now. Okay, so what is a module system? How do OSGi and Jigsaw compare? Given that Java 9 is now out and Jigsaw or JPMS is now out in the wild, is OSGi even still useful? And can OSGi and Jigsaw work together? That's my agenda for today. So I'll do some brief high-level comparisons and talk about what a module system should achieve, and then how these things can work together. So a module system needs to provide isolation of module internals. That goes to what the keynote was saying about David Parnas and hiding implementation details and so on. It needs to provide controlled and scoped dependencies. It needs to provide defined modes of interaction, how modules communicate with each other, and it needs to provide a life cycle. So let's talk about isolation. So the purpose of isolation is to prevent the leakage of implementation details and to enable the distinction between public and private, so I can hide things inside my module so they can't leak out. And the reason we do that is it means as the implementer of a module, we don't have to provide ongoing support for things that are private internals, because we know that people can't depend on those private internals. A quick refresher on, this is basic Java, it's nothing to do with OSGi or Jigsaw. This has been Java from year one. The way accessibility works in Java, so there is a concept of visibility and another concept of accessibility. So if you see this public class C here, it can access this public class A. First of all, because it's in the same class loader, and also it's an accessible class because it's public. Okay, that's accessibility. First, do I even know that the class exists? And secondly, can I access that class? The public class C cannot access class B because it is not public, it is default access or package private. And then there's this other class over here, public class D, which is not visible because it's in a different class loader. Now, a key point of the accessibility is that it is checked by the Java compiler. It doesn't always check it absolutely accurately because of a concept called runtime packages, because the Java compiler doesn't know how the class loaders are going to be arranged. But the Java compiler is checking for accessibility, and it will return an error on this layout if I try to access B. Now, how does Jigsaw implement isolation? Jigsaw adds additional access controls within the class loader. So here I have package Baz in module B. Module B requires module A over here. Module A is exporting package foo. So because of this arrangement, public class C over here can access public class A over here. It's an exported package and it's accessible. And that is enforced at compile time and runtime. However, public class C cannot access public class B because public class B is in package bar, which is not an exported package from the module on the left. However, it can see it. It does have visibility. If I were to use reflection, I could get hold of that class, but I just couldn't instantiate it or call methods on it. Even incidentally, if I do something like set accessible true. So Jigsaw is actually kind of changing the semantics of what public class means in Java in order to implement this. Quick bit of audience participation here. Two Jigsaw modules, module A and module B. This one exports package foo, this one exports package bar. By a show of hands, who thinks that both of these modules can be installed together on the module path? Because, yeah, there doesn't seem to be any conflict, right? By a show of hands, who thinks they can't? And anybody who didn't put their hands up the first 2 times? And I'm sure there's some who didn't put their hands up even the 3rd time. Yeah, the 3rd people are right. Okay, you do not know. There is not enough information. Because modules cannot contain the same packages, even private packages. So the module descriptor there doesn't tell us anything about what the contents of A and B are, what private packages they each have, and therefore there can be conflicts that are just not known, at least in the module descriptor. So Jigsaw Isolation is pretty much incomplete. It's still exposing internal details. I have to know the internal details of other modules. And the module info Java is incomplete as a module descriptor. Whereas an OSGi manifest, I can always look at a manifest and work out, can I install this, and what would it provide if I did install it? The Jigsaw descriptor doesn't give us that. And this is all because modules on the module path still exist within one class loader. Going back to this diagram, all these classes are still in the same class loader, so I cannot have 2 copies of this package bar with public class B loaded by one class loader, because that semantics hasn't changed, one class name to one class within a particular class loader. Okay. So that's a very high-level view of isolation. Let's look at dependencies. So isolation is isolation is about building walls between things. And anybody can build a wall. Almost anybody can just build a wall. Right. What's more important or more interesting is actually working together. Once I've built the wall, how do I then re-enable controlled cooperation between these things? So punching holes in the wall and giving us controlled access to module features. In other words, API. The way OSGi handles dependencies is on the concept of a capability. When I'm an OSGi bundle, I provide a capability and I require capabilities from other bundles. So a provided capability can be something like, I provide a display and it's got some attributes on it. And a specialization of the capability idea is a package, an exported package. It's just another kind of capability. So I'm exporting that package with that version. And then another module or bundle can require those capabilities, the display with a filter, or require a package. So the key concept here is that we depend on what a bundle can do, what it can provide, rather than who it is, rather than its identity. And that's because different bundles can implement the same idea in different ways. And that's a very important concept. So Jigsaw dependencies, by contrast, are entirely based on identity. So I'm a module B, I export some things, and then I say requires A. So I'm requiring the identity of a module. This means that no substitution is possible. I have to have module A. It must be module A at compile time. It must be module A at runtime. It cannot be an alternative implementation of the same API. It must be the module with the identity A. As a result of that, there's no substitution possible, and this essentially makes the identity of a module its API. So A is both the identity of a module and the identity of the API that it provides. And that means that if you have multiple artifacts providing the same API, for example, if you have SLF for J API and log for J over SLF for J, those kinds of adapters, they must have the same module identity. You cannot provide a different module identity because you've got to write in the module identity you're going to depend on. That's never going to change. And versions, we all probably know this. There are no versions in Jigsaw. This is officially somebody else's problem. Jigsaw kicks this problem down the road. It says it's a problem for tools, for Maven, for Gradle, or whatever else. It's the application assembler's responsibility to assemble an application with modules with a consistent set of versions, but we're not going to tell you what the version of anything is because that might be too helpful. Okay, so let's compare this with OSGi. Why is Jigsaw like this? Well, Jigsaw successfully solves the problem that it set out to solve, and that is to modularize the JDK. They have done that successfully, right? The JDK, excuse me, the JDK is a single vendor product. It's released as essentially a monolith. They've modularized the internals, but it's a monolithic release. It's not assembled from multiple third-party components, and it's released all at once, and it's released infrequently. So if I'm releasing the entire thing all at once, then I don't need to care about versions, because I know that the only version present is the only version that I can use. So, so it does have that kind of advantage going for it. The other thing that the JDK has going for it is that it's got about 9 million developers. That's Oracle's estimate. Approximately 9 million Java developers in the world, and probably billions of applications running this stuff, all depending on this API. And so changing that API is very hard, if not impossible. You can't just refactor this into a better modular structure, which is why using something like OSGi, a pre-existing approach, was challenging for modularizing the JDK. So JDK is unusual. Typical Java applications aren't like that. They're assembled from many sources. We pull in third-party components, open source components. We assemble applications from our colleagues in another team down the hall. We have all of these components and libraries with different release cycles. And I have to release more frequently. You know, it's been about 3 years since Java 8 was released. Now, Java is trying to speed up to have a release every 6 months. Don't think it's going to be particularly practical, but they don't have this time to market pressure that your typical Java application does have, because people are still going to use Java even if they don't get Lambdas this month. So OSGi has been addressing exactly this kind of scenario for 18 years. And that means doing things like versioning. We need to have versioning to enable the multiple non-coordinated release cycles. The requirement capability model to allow for substitution. The resolver, the service registry, and generally just flexibility. So in the ideal scenario, we want the best of both worlds. We want the Neapolitan ice cream. We want to have the modular JDK, as provided by Jigsaw, with a modular application powered by OSGi. That would be the best of both worlds. And that will be great. That would be very, very useful. But we need to check it actually works. So, a quick word about how Java 9 provides for backwards compatibility. So Jigsaw implements 3 main strategies for supporting backwards compatibility. The first is class path and unnamed modules. I'll come on to that in a second. The second is automatic modules. And then the third is that essentially most of the illegal access controls are actually turned off by default in Java 9, although they may be turned on by default in future Java versions. So the unnamed module does still exist in Java 9. The class path does still exist in Java 9. And all the types that we put on the class path are loaded into an unnamed module. Unnamed modules implicitly require, which in Jigsaw terminology is read, all of the named modules on the module path. So they just depend on everything implicitly. But they cannot read unnamed modules. Sorry, named modules cannot read or depend on unnamed modules. So the dependency can only flow in one direction. The unnamed class path space can depend on everything in the named space, all of the named Jigsaw modules, but it can never go the opposite direction. Because of this compatibility layer, this does mean that in theory, running any standard Java app on Java 9 should just work. And many applications do just work. There are some exceptions because of things that have been changed, but essentially it does kind of work. The second approach is automatic modules. So Jigsaw provides the idea that I can take a plain jar, something that was never designed for Jigsaw in mind, and it doesn't have a module descriptor, the module info Java, and simply drop that jar file onto the module path. And Jigsaw will treat it as a module. It's something called an automatic module. So it is a named module, and because it's a named module, other named modules can depend on it. And those automatic modules, like the unnamed module, they implicitly read every other named module, and they also export all of their contents, because there's no information in there about what should be private and what should be public. But this as a migration step does mean that named modules can depend on the automatic modules, although there's some question about naming and the stability of naming. So let's look at some levels of interoperability that we can have with OSGi and Jigsaw. First level, which I'm calling level 0, is basically just running this stuff. All three principal OSGi frameworks do run on Java 9 today. Right? They run, they work, all the test suites pass, and so on. That's fine. I don't have any information about others like Concierge. I'm sure it's a pretty good story. They work in the class path compatibility mode, which means that OSGi framework and all of the bundles that you install will be in the unnamed module. When you run Felix framework, which is the only one I've tested here, it requires only the Java-based module, which is pretty nice. It doesn't depend on any of the other extension modules in Jigsaw. There are some illegal reflective access warnings, which we'll have to deal with eventually, but nothing major there. More of a challenge is that in OSGi, in particular in Felix, we have these hard-coded package lists, the list of exported packages from the system bundle, which reflects the Java SE standard packages. So a problem is, for example, the system bundle is exporting javax.swing, amongst many others. Javax.swing in Java 9 is exported by the module java.desktop. Java.desktop is a module that can be removed from the platform, which creates a problem, because if there's no Java desktop module, but the OSGi system bundle is still exporting that package, the javax.swing package, then somebody could get class not found exception, or no class def found error, which we should never allow to happen in OSGi. Another problem is that OSGi bundles cannot import any package in the Java dot namespace. This is actually a security restriction that's always existed in the Java platform. It's not something that OSGi just is limited by. We cannot import java.star packages. So that means we can't use versioned import packages to get hold of the right version of a particular java.something package. So how do I check my compatibility in OSGi? How do I know whether I can call the string.isEmpty method, which was added in Java 6? Well, traditionally we've used this thing called an execution environment. So when I generate a bundle, BND will add a required capability, a requirement for the OSGi.e namespace version 1.8, if I've compiled against Java 1.8. Right? So this says this bundle requires at least Java 1.8, which works great up until Java 8. But the problem is an execution environment essentially describes a monolithic platform, because that's what we had until Java 8. We did have special execution environments for the three compact profiles that were available in Java 8. They're still essentially monoliths. The problem in Java 9 is that now some java.star packages can be removed. So how are we going to cope with this? So let's look at the next possible level of interoperability. We can calculate the system bundle exports using the JPMS Module API. We can detect if we're running on Java 9, and if we are, we can inspect the set of modules available in the so-called boot layer. There are some issues which we're working through, but this is working experimentally in Felix right now. So I will quickly switch to Eclipse here. And I have a Java runtime, an OSGi runtime. One of my bundles is creating a little trivial swing panel there. So one of my bundles depends on swing. So LB, and there's my java9.simple, which just says hello world, and java9.swing. Right. That works fine because I'm running on the full JDK. I can then switch to an alternative JDK. So what I've done is I've used the JLink tool that comes with Java 9 to build a cut-down JDK. So this JDK I've just selected contains only Java base and Java logging. Java base is required by everything. Java logging is required by the GoGo shell, not by Felix itself. So if I run on custom JDK, I run, and I get a resolution error. So the swing bundle cannot resolve, which is correct, right? So the swing bundle doesn't resolve. We don't get class not found exception or no class test found error. We get a proper resolution error. The other bundles that and the reason that works is if I say inspect cap OSGi wiring package 0. So this is going to give me the list of all of the system bundle package exports from from the system bundle. And there's quite a lot. This is done by introspection of the JPMS modules, all of the exported packages. You see there's some in here that you never even heard of, JDK internal util XML impl, interesting, but that is exported API from these Jigsaw modules, so it's there. So, so that works for JavaX.packages, JavaX.style packages. So it fixes the problem for the Java SE packages like javax.star, also org-w3c DOM, org-ietf.jgss, and all of these things. It does not fix the problem of java.star dependencies because the execution environment is no longer sufficient to solve that problem because the execution environment is no longer a monolith. Bundles now need to indicate their Jigsaw module dependencies. So a combination of the Jigsaw module that you depend on with the java.packages. So for this proof of concept, I've invented a new capability namespace called JPMS Module. And in my bundles, I've generated a required capability, JPMS Module equals java.sql, if that's a module that I depend on. So I've got BND generating this. Obviously, I wouldn't want to write that manually. BND is generating this. It's using the JDEPS tool from Java 9 and putting this in the manifest at build time. And I'm also making sure that my hacked Felix implementation provides the appropriate capabilities depending on the platform that I'm running on. So I go back to Eclipse. I've terminated that. So if I come into my simple example here, it was running just fine on my very cut down Java 9 JDK. And I'm going to add something that I know is not in that JDK. I'm going to use some SQL. So java.sql connection. Now there's no need to actually do anything with it. Making it a field is going to create the dependency. So now if I look at the bundle that gets built, looking at my target, and have my resolution view open, I can see that BND has generated, sorry for the size of this, but I have a dependency on JPMS module Java base and on JPS module java.sql. Oops. So now if I run that same application on the same
agree on what
I get another resolution error. So now my simple bundle doesn't resolve, and the resolution error is unable to resolve, missing requirement for JPMS module java.sql. And if I look in inspect cap JPMS module 0, so those are the JPMS module capabilities provided by the system bundle in this hacked Felix. And obviously, we could extend BND and BND tools tooling to have better support, so I can do this resolution in the IDE. I can resolve against a particular JDK with whatever modules that JDK contains, and so on. There's quite a bit we can do here. And so what this effectively means is right now, OSGi bundles can depend on JPMS modules. We can make an explicit defined dependency on a JPMS module. This is possibly something that should be included in the OSGi core spec. So that's something for the OSGi CPEG to discuss. However, there are still some issues with this. So there are obviously a lot of legacy bundles that won't have this JPMS requirement in them. That is, when I say some legacy bundles, I mean every existing bundle in the world today. So the problem, of course, if I don't have JPMS module requirement, then I don't know whether that bundle should resolve on any particular platform. But if I do have the JPMS module requirement, then that bundle will never resolve on Java 8 or below. So it creates a bit of a problem here, a bit of a migration problem. This is something that we'll have to work through. Maybe that means I should be running the JDEPS tool on the bundle on the fly as I install it rather than at build time. So there's some options around that. So that's a base level of interoperability, and I think it's already pretty good because it provides the interoperability and the dependencies flowing in one direction. Can we ever do fully bidirectional interoperability? Very unlikely that will ever work. Because a Jigsaw module, by design, can only depend on a Jigsaw module. Right? If we try to wrap an OSGi bundle as a Jigsaw module, or pretend that it's a Jigsaw module, or try to mix together Jigsaw modules with bundles, we lose, first of all dynamics, because the Jigsaw module graph can never be modified. We lose other features like split packages and cycles. That's not to say that those things are good things to do necessarily, but they are sometimes necessary things to do. And we would break a lot of software if we were to remove those. Another option that we might like to do in the future is it would be nice if we could take the access control that's offered by Jigsaw and use it ourselves in OSGi. So one thing that you might know in OSGi, I can always go to a bundle and use reflection to load classes from inside the private packages of a bundle, right? So I can't easily depend on them at compile time, but I can use them via reflection. Of course, I can use Java 2 security to prevent that. There's an existing mechanism if I want to prevent that in Java, all the way back to Java 1.2, which is the Java security. Not very many people turn on Java security, so it might be nice to use the Jigsaw feature to enable that access control as an alternative to the Java 2 security approach. That cannot be done with the way that Jigsaw has been designed in Java 9, because you have to go all in on the entire module system if you want to use that access control between a couple of classes. So that's not possible today. Maybe possible in the future Java, if Oracle does some work on evolving that API, but who knows. Can we load OSGi in a Jigsaw module? So rather than stuffing everything into the unnamed module, can we have a named module so that OSGi framework and all the bundles run in that named module? If we do that, then it might give us more control over the access to the platform. Also can't be done as Jigsaw is today, because the content of a module is immutable. Once the classes are in the module artifact, I can never add to my module, even reflectively, even from within my own module. So if I'm running this code inside a module, and this is like, this is like any OSGi framework would do something very like this in a very simplified way. Create a class loader for a bundle, given the bundle class path, and then load a class from the bundle, and then have a look at which module that class belongs to, and this will tell me this is the unnamed module. This will always be the unnamed module, even if I'm running this inside a module, a named module, right? So the module content is immutable, and so we would never be able to load a bundle if we were to do this. We tried to ask during the expert group discussions, we tried to get an add packages method on module. So there's various methods for mutating modules. I can add exports, I can add reads, I can open packages and so on reflectively at runtime, as long as I have the right permissions if I'm in the module that's trying to ask for these things. We didn't get those, that was rejected by the spec. So we can't, sorry, we did get some of those, but we didn't get this add packages method that would have enabled this scenario. Again, maybe we'll get it in the future. A quick word about an experiment that Tom Watson at IBM did, and I apologize to the IBM employees if I'm getting some of the product naming things right, but at least I'm not constrained by the IBM marketing department. IBM has a particular problem, which is that they have application server products, things like WebSphere and Liberty. In the future, IBM customers using those app server products may need to deploy applications that consist of Jigsaw modules. That depends on the future evolution of Java EE. The problem, of course, is that the application server products are written in OSGi, but Jigsaw modules can only depend on other Jigsaw modules. So there's this bit of OSGi in between the base platform and the potential future Jigsaw modules that the customer might want to write. Jigsaw modules can depend on Jigsaw layers. So Jigsaw has this concept of layers, which are groups of modules arranged in hierarchies with inherited readability through that hierarchy. So what Tom did is extremely clever. He dynamically mapped subgraphs of the OSGi framework where he was able to find regions of the OSGi framework graph that didn't have any, for example, cycles or any split packages. He was able to map those to single layers, but sometimes he had to create additional layers. And dynamically compute a set of layers and on-the-fly generated Jigsaw modules to map the OSGi layer, as it were, and then allow some Jigsaw modules in an application to depend on the contents of the packages exported by that layer. This is not fully bidirectional interoperability between the two module systems, and it is fairly complex and computationally expensive. You can see his experimental code on GitHub, so get the slides later if you want to find that URL. That's the approximate diagram. That's my understanding of what Tom did. Another possible approach, let's just pretend it's a bundle. Jigsaw metadata is almost a subset of OSGi, and OSGi functionality is pretty much a superset of Jigsaw functionality. So let's just take a Jigsaw module, pretend that it's an OSGi bundle, interpret, map the metadata that comes from the Jigsaw module into OSGi headers, like requires become require bundle, and so on. Relatively simple to do, but there's a huge loss of information. Goodbye all the nice stuff about import package, capabilities, resolver, and so on. And of course, goodbye versions. No versions at all. And also, the service loader doesn't really work. You know, the way Java 9 modules are going to be written is to use service loader to talk to each other, and the service loader will require a lot more interception and bytecode engineering in order to make that work in this kind of model. So this approach seems simple, but it may be of very limited utility. The other sort of concern is that once we're telling people that they don't need to write OSGi metadata anymore, that's not going to do good things for the state of OSGi metadata in the world. Nearly done, Dan. Another possibility, I'll skip over this quickly, just abandon the OSGi module layer and move up the stack and implement the OSGi service registry on Jigsaw. Again, relatively simple to do, but again, we're losing a huge amount of very good functionality. The requirements capabilities model in the resolver is really an unparalleled model, which I would be very, very sad to lose. So, some good news. Jigsaw is great for modularizing JDK. OSGi is fantastic for modularizing applications. And they already work together. So, no real big problem here. And there's some great opportunities to say, let's take some enhanced B&D tooling, plus the JLink tool that comes from the JDK, and generate these very tiny application images. So we could be talking about complete applications, including not just the OSGi bundles, but also the JDK, everything in tens of megabytes. So I would say the future doesn't have to be scary, so maybe I'll stop using this scary clown mask and start using this much more fluffy Jigsaw to represent the Jigsaw platform. Okay. Marketing message to drive home from me: Jigsaw for the JDK, OSGi for apps. Thank you very much. Do we have time for questions? Oh.
We have, we're actually at